In this video, I'm going to walk through an addition that I added to my system, which is a USB mouse. If you've seen some of my older videos, maybe on my 65816 or my 6502 builds, I had hooked up a USB mouse through an Arduino using a USB host shield, and then I was just kind of tapping into an 8-bit type of bus to send over movement information like left, right, up, down, button up, things like that. And that was okay, but it wasn't the smoothest. It kind of had some diagonal attitude, I guess, when it came to the mouse. It didn't always go exactly in a nice smooth pattern. I want to show you this way that I've set it up on my 286, and I've actually got a much smoother mouse than I've ever had before. So I'll kind of walk through maybe how I've set this up. And let me start by turning on my system. And so I go through the normal initialization. I initialize my video to black right away. And then what you see here is I now have this mouse cursor. And I'm just using a circle for now. So wherever I move the mouse, this circle follows. And if you've seen my previous videos where I had a mouse, this is really smooth. I mean, it's not going in any weird diagonal shapes. I can go in a nice arc, and it kind of is just smooth, I guess. And so, as I'm doing this, of course, I'm leveraging my video card, and I'm drawing a circle, and I'm flipping a frame, and I'm erasing the old circle, and then the next time I move, I draw a circle, erase the old from the other frame, and I'm constantly swapping frames on my video card. So that 2-frame capability is really nice when I'm doing this. It just helps make this mouse really smooth as far as the screen draw. You will also notice that all of the noise is pretty much gone from my system. I posted a couple of updates, but I had to disconnect power from my Nano and my USB hub, and instead I'm powering it off of my 286 board. Plus, I have an active VGA splitter coming out of my video card, and then out of that I go to my LCD screen, and I also go to an HDMI converter, so VGA to HDMI into my USB capture device. And this setup appears to have gotten rid of all of the noise, so I'll be curious when I watch this video back if there is much noise on here. But between that, the dual frame there, and the way I've set up this mouse with this connection, which I'm going to talk about, it's a pretty nice experience. I'm definitely not going to complain for a 286 computer. Now I am going to admittedly say I'm cheating on this. This is not 286 era solution here, but I want a mouse, and I've got some other parts on order to maybe try some alternate ways of doing this. But until I get that stuff in and can maybe design a solution, this is what I'm going to be using. So the basics of this is I've got a USB mouse plugged into a USB host shield that's sitting on top of an Arduino Mega. Now that shield and the Mega communicate through SPI. So the Mega's communicating to the shield through SPI. It's using the hardware SPI implementation. Now in my previous builds, before the 286, if I go back to my 65816 or 6502, I did something similar, except for to interface, I was actually running a bunch of signals, basically to show if I was going left or right, up, down, button press, or diagonal, etc. I'm not doing that on this one. I'm actually using SPI. And I have a temporary solution in place right now where the 286 is just polling for the mouse data, and it's making SPI calls to the Mega. Now at some point I'll change that to an interrupt, so I'll have a pin that goes from here into my programmable or priority interrupt controller on my 286, and as I move the mouse it'll throw the interrupt will read the mouse data, and so basically it'll only do something when I'm actually pressing buttons or moving the mouse. I'm not to that stage yet. For now, I just wanted to see if I could use it in a polling mode and actually get it to behave the way I want it to. And if I make it through this, then I'll move on to getting that interrupt connected. Now, one of the challenges I ran into, though, is this Arduino Mega. It has one set of SPI, and it's a master to the shield. So that means if I want it also to be a slave to this 286, I can't use the SPI hardware. So I have to use SPI, a software implementation. And I could not find an existing software implementation that allowed it to be an SPI slave. So the 286 the master, I want the Arduino as the slave, and support interrupts so that basically when I make a call, that causes an interrupt on the Arduino to then actually go get the mouse data and then respond with the rest of the SPI sequence of here is the mouse data. So I kind of rolled my own, and I'll show you that code here. It's not crazy complicated. It was actually quite a bit easier than I thought it was going to be. So from the 286, I'll make a call, an SPI call to this. I'll say I'd like to send a byte that's an SPI command. Command, for example, could say get me the mouse data. And then I'm returning 3 bytes. So the next 3 SPI calls for bytes, the next 3 bytes that I retrieve, are the data that correspond to the mouse. Where is my X, where is my Y, and what is the state of my 3 buttons, left, middle, and right? Are they down or are they up? And so now I just got these 4, obviously my MOSI, my MISO, my cable select or chip select, and then also the serial clock. And so that's all I'm running between these 4. And then I'm doing the processing and setting up an interrupt so that when I do get the MOSI, sorry, not the MOSI, the chip select drops low, that triggers the interrupt to start processing SPI with my software implementation of SPI. And then once the 286 receives back the data, then it's actually got to do something with that data. Now on the Arduino, I am not just tracking direction of the mouse, I'm actually tracking which pixel, where should the cursor be within my 640 by 480. So I have a 640 by 480. And as I move the mouse, I'm tracking the position that it should be at. And then when the 286 calls and asks for mouse data, it's getting the XY position of where that mouse cursor should be. And that's giving me this really nice, smooth type of behavior. So maybe point out one more thing here. All I have running to the host is just power. So this is not going to any PC or anything at this point. Everything is self-contained. All I have to do is feed it power. And at some point, I'll probably pull that power from up here. But for now, I've just got this sitting here so you can see it's just power coming into it. And then the host shield connects through the pins on the host shield right into the SPI pins below. And then my SPI here is connecting to SPI here. Now, if I go look at the Arduino, this is the code that you see here. And down to the right, you're seeing an output of my serial when I did have it connected to my PC just for troubleshooting, debugging. But as I was moving the mouse, it was showing me X, Y, and then button status. And basically, I've got 3 bits, 1 for each button. So I'll either get a 0 up through a 7. So if I had all 3 buttons down, I'd have a 7. All 3 buttons up are a 0. And each button has a value of a 1, a 2, and a 4 accordingly. But in my code here, this is the Arduino code. I've defined the pins, and I'm using these pins 18, 19, 20, and 21 on my Arduino. And I'm basically saying that's my MISO, MOSI, serial clock, and my chip select or cable select, or slave select. I think sometimes you'll see it SS also. But if I go down in this code, and I'm going to maybe bounce around a little bit, but let me just show you in the setup. I am connecting, if I want, to the serial on the PC just for logging this type of stuff over here so I can troubleshoot. I initialize the USB host shield, basically, and then I have this basically HID mouse .set report parser lets me actually start getting back mouse data. But then for the SPI code that I implemented, I attach an interrupt to my CS. And so that CS would be this far right pin down here. But basically I'm saying anytime that falls from a high to a low, go run this interrupt service routine called ISR SPI port D. And then I set all my pins to input. Even the output pin I set to input because I want it kind of in a tri-state. And I think on the Arduinos, that's the closest you're going to get to a tri-state. Set it into input so it's not messing up other things on my SPI bus. For example, on this SPI, I also have my real-time this real-time clock down here that shows temperature and time over here, and you can see that that's working fine with this on there too. And then in the normal loop, I just simply have this call to USB task, and that's doing some background stuff, and that's just part of a library that I'm using. So I didn't write anything for that, but I call that, and then I'll have some interrupts to handle the different mouse behavior within the Arduino. And then I've got a little flag that just says I've got SPI data coming from my 286 that I need to do something with, or have received some data that I could show if I want to show it. But if I get out of the setup and loop for a minute, a couple of things. There's like a mouse move. And in that mouse move, that's where I'm just putting in the logic that says, you know, check basically how much the mouse has moved, figure out within my 640 by 480 what is the position that it should actually be at. And that is a screen pause X and a screen pause Y. But I then take those screen position, I bring them together along with the button state, which is 3 more bits, and I put it into a variable called dword descend. And then anytime that I, from my 286, call this through SPI, it hits this interrupt service routine, and that interrupt service routine then basically has to pay attention to the CS, it has to pay attention to the clock, am I high, am I low, so I have to wait for that clock to go high while my select is low, and then from there I can actually then go update, and this code is just updating my MISO line, so it's the return data, and that return data I basically grab a bit out of that dword descend. So that's 32 bits. The first 8 bits are just garbage. I just send back 8 bits. It doesn't matter. But then the next 24 bits would map to my mouse data, which I have laid out in something that looks like this format. 2 zeros, but those don't matter. But then I have 10 bits for the X position, 9 bits for the Y position, then my left, middle, and right mouse button status. Is it selected or not? Is it down or not? And so I'm writing out my MISO, then I turn around and I read in if there's anything coming in on Mosey. And when it comes in, I might read and check for maybe a certain command or something like that. I'm not doing that right now. I'm just reading in the value, and I'm receiving the value fine that I sent from my 286, but I'm not doing anything with the value. But then the next 24 bits that I send back on MISO is all that mouse data. So this is the routine basically that is watching my CS line coming from my 286 SPI, and when that is dropped low, it then processes, and it essentially goes through 32 bits of processing. The first 8 bits are just to receive a command coming in Mosey. The next 24 bits are to send back basically 3 bytes of response data to that command. So that's the essentials of what's going on inside of this Mega right here. And if I go over to my 286 code for a minute, you know, I'm still running the 8 megahertz processor clock at this point. That really isn't going to change. I don't think I'm going to try to speed that up or slow it down at this point. I would say that in the code I have here so far, there is a lot of room for optimization. I have some intentional delays. I'm going to go back and try to trim down those delays and things like that. But let me just walk through what I have. Now in my startup code, you know, I go through all my normal things like initialize my VGA, which sets it all to black, and you know, do a bunch of other stuff here. Get my SPI up and running. Get my basically my startup tests over here. My post routines all run, and you see the results there. You know, I get my LCD up and running, and I show the temperature and time of day from the real-time clock. You know, that's all of this stuff in here. But then I get down eventually, and I want to go ahead and, you know, start checking for the mouse. And the way I'm doing that is just inside of the main loop. So after it gets done initializing everything here, it falls in or keeps running into this main loop. And the first thing I do is I check for keyboard. So keyboard gets priority here. And if there was nothing to do with the keyboard, then I go ahead and proceed with getting the latest mouse data. And once I get the mouse data, then I turn around and draw the mouse pointer based on that data. So let me show you what that get mouse data looks like. And so in my get mouse data, I am using SPI mode 0 here. And if I come down into this, I'm basically going to call a previous routine I wrote called SPI read byte port A, except for I made a slow version. And what I did in the slow version, I just got a little bit of extra pauses in between changing my clock lines, just so that this Mega can keep up with the software SPI implementation that I'm using. Not huge delays, but some delays, and I think I can actually back those off a bit. But I basically have 3 read bytes, and before that I have a write byte. So I can send it a byte of data, which I'm just sending this 11001100, just so I can recognize that pattern on the Arduino. Not doing anything with it, but once I receive the first byte, I then say read byte 3 times. And in SPI, when you read a byte, you actually send a byte and you read back at the same time the 8 bits as part of that. So basically here I'm going to send over a byte with maybe a command number, and then I'm going to read back a byte, and a byte. And as I read back those bytes, I'm essentially reading back this information. So I'm reading my part of my X position, the rest of my X position, part of my Y, the rest of the Y, and then my left, middle, and right button status. So then I've got to, of course, pull those out, put them into the right, get all my X stuff together into a single word, get all my Y into a single word. And that's what you're seeing in this code. I'm just filling in a mouse pause X and a mouse pause Y that basically remember XY position of where my mouse is at. And then, of course, I store the button data down here also. Now, once that's done, then I can call this draw mouse pointer from that loop up above. And really what I'm doing is this down here. So I'm going to call this draw circle, a filled circle procedure I wrote, and I showed a little bit of that in a previous video. And basically saying draw it wherever that mouse is at. So get the X, get the Y. I want a radius of 4, so that's how big I want it. I'm going to just draw it in white. And once I draw it, swap frames. And once I swap frames, then go to the other frame that is no longer active, grab the previous mouse location, and fill it in with black. And then do not, after you draw the circle, do not flip frames again. Not needed yet, but then go ahead and remember my new mouse is now the old mouse position. So this is just the routine that as I move my mouse across the screen, it's going to a frame, drawing the circle, going to the old frame, erasing the circle. Next time I move again, it reverses. It draws it over here, clears it here. And it's just doing this toggling back and forth. Now, of course, in the future, I've got to get more complicated than that. I've got to be able to track what was the old data in that location so that I can restore it, not just black. So if I move the mouse over something, it doesn't destroy that, whatever I'm moving over. And I've done that type of work on my 65816. So I just have to basically apply the same logic and get it implemented here in x86 code. But that's really it. So I've got the draw mouse pointer now, and it's going to use the data from get mouse data. The get mouse data is making an SPI call to the Arduino to fetch the latest mouse data. And then on my screen, as I move around, you then can see that. And right now, like I said, I've set this to clear the previous one with black. So if I was to go to a white screen, this is going to look really bad. I'll do it anyways, though. So F5 was to clear my screen to black. F6 was a clear my screen to white. And so that's going to give me a white screen. But now as I move, you can kind of see the result I get. But you can kind of see that flicker a little bit. And that's because I'm clearing to black instead of clearing to white. And obviously if I get both frames covered, I can get rid of these. But if you see the flicker, it's because one of the frames was cleared with black and the other one has some white on it. So you're seeing a toggle between a white and a black. That'd be easy to fix. Of course, I would just swap and say draw with black or blue or something and clear with white. But you can see here, and now if I move the mouse fast, you can see kind of the distance that I get. If I go slow, you can kind of see the behavior that I get. And this is not meant to show anything impressive other than, you know, I'm moving the mouse and it shows you a little bit about the behavior when I'm using an inverted screen. But if I go back to my F5, which is to clear it to black, of course you're not going to see that. You're just going to see the way I intended it. Or if I would go to like, let's see, F6 was my white. Maybe let me go back to my test screen. And this test screen takes just a second to generate, but there is my test screen, and you can see what everything currently looks like and my ship coming across. And I'm not seeing any noise on the screens. The LCD has never had noise, but I don't see any on the recording on OBS as far as I can tell right now either. But I can now move the mouse down here in the black, and you can see the behavior. If I go over the text, of course, I can erase my text because I'm clearing to black basically wherever I trail. Now, this obviously will lead into where I can start using my buttons and I can start drawing, and I can flip colors and fill in and erase and things like that. So that's not a stretch from where I'm at. It's just a bunch of coding at this point. And then F8 was to get to another screen, which is my shapes, but that's just the same, going to be the same behavior. Now in this case, I was only filling those in. Oh, that's annoying to look at. I only filled one frame in with my shapes. The other frame I did not populate, but my mouse pointer is constantly redrawing the way I have it set up right now. It's just in that loop, and that causes it to toggle frames. So you're seeing one black frame, and then you're seeing a frame with the shapes. Now the mouse data is showing up properly. It's drawing on both frames back and forth. But boy, is that annoying to look at these shapes. So maybe I can erase them if I want, just by going over them. But hopefully that makes sense what I'm doing there. Let me go back to F5. And that's probably, you know, a pretty good overview for now. So short of it is I have a Mega, I have a USB host shield, my mouse is connected to it. I've written support so that I can make an SPI call from my 286 to the Mega, and the Mega makes another SPI call over to the mouse to get mouse data. And it's constantly tracking and storing that in memory, and I can read that whenever I want. So I now have a Mega that's both an SPI master and an SPI slave simultaneously. And all of that seems to be working pretty well. So that's maybe all I've got. Maybe one little side note, just for those that are paying attention to the series. I did go in and do a bunch of just voltage testing. I kind of wanted to see how is voltage flowing through all this. You know, I had a little bit of concern. Would I be getting, you know, all the voltage I need to this card? And I'm getting almost no voltage drop. It's really good, quite honestly. From the voltage I'm getting here to like the worst case is maybe 30 millivolts. It's not much at all. So I'm keeping all the way through this worst case spots that I could find, all the way up into the card, the very corner of the card, anywhere. I'm not getting much for voltage drops at all. So maybe 50 millivolts tops, and that is probably on the top end. So I'm really happy with this 286 board and with the updated VGA card. I am going to pull out all of the resistors on the VGA card sometime later this week and flip to some different levels or values for those just to try to get my impedance better matching or closer to 75 ohms. So I had a bunch of feedback on my YouTube channel. Thanks everybody for that. It just was saying that, okay, maybe my impedance still wasn't quite where it could be. And I did put up a post based on some nice feedback from Liquid Nyquist on that. So took some of the thoughts from Liquid Nyquist and tried to digest it and then put it back out in a format that others might be able to benefit from. So that kind of shows the calculations and a little insight to what values I'm going to use on that resistor, that R2R ladder for my DAC on my VGA. So that's probably it for now. I see I'm past the 20-minute mark already here, so I'm trying to keep these under 30 minutes. If you have questions, comments, suggestions, feel free to throw them down below on the YouTube channel or hit up my blog page. The coding that I'm showing so far on this is all just prototyping type of code. I know there's a lot of optimization. There's probably a lot of things wrong with my code, but it's really good practice for me to just kind of work through these things and try to make this stuff work. So, and as always, I've appreciated all the feedback on the assembly coding side of things too. I continue to implement the recommendations I've been getting as I go. Thanks for watching another video in the series, and stay tuned for the next one.